Let's do another example. 3 raised to power 5x minus 6 is equal to 2 raised to power 4x plus 1. We need to solve this, meaning we need to find the value of x. Now, this is an exponential equation. Base on both sides is not matching. One side is 3, the other side is 2. So, equivalence of bases not work. What we're going to do is take log on both sides. You can take any log, common log or natural log. I'm going to do this one using natural log on both sides. So we have natural log of 3 raised to power 5x minus 6 is equal to natural log of 2 raised to power 4x plus 1. Now, because of the power property, power comes down. So this will come out. This expression will come out. So we have 5x minus 6 times log of 3 is equal to 4x plus 1 times log of 2. We can use the distributive property to make log 3 inside with everything. 6 times log of 3 is equal to 4x log of 2 plus 1 times log of 2 would be just log 2. Now we notice that x terms are both sides, so we need to collect them, isolate x terms. So we have 5x log of 3 minus, when we bring that on the left side, it becomes negative. Similarly, we need to take the constant terms on one side. So that would be log 2 plus 6 log of 3. X is a common factor in both of them. We can factor it out. 5 log of 3 minus 4 natural log of 2 is equal to natural log of 2 plus 6 log of 3. So we finally, this whole thing is just a expression, okay, which we can find using calculator. So x is equal to natural log of 2 plus 6 log of 3 divided by 5 natural log of 3 minus 4 natural log of 2. Let's try to calculate it using calculator. First expression we have is natural log of 2 plus 6 natural log of 3. That is 7.28 approximately. Denominator we have 5 natural log of 3 minus 4 natural log of 2. That is 2.72. We can divide both of these terms. 2.67 rounding off 68. So x is 2.6. Here we have in example 5 a exponential equation, but this looks like in a quadratic form. Let's see how. If I can, in place of e raised to power x, I can write u, suppose. This is e raised to power 2x, so that is u square minus e raised to power x, I am assuming that is naming u, plus 12 is equal to 0. Now this does look like a quadratic equation, but u actually is e raised to power x. So we can factorize it. This is a quadratic equation. So you factorize it by splitting 8u into two expressions such that they can add up to be 8u. So let's try this, and their product should be coming out of the outside numbers. By factoring, I have u minus 6 times u minus 2 is equal to 0. So either u is minus 6 is equal to 0 or u minus 2 is equal to 0. So u is equal to 6 or u is equal to 2. But we were not supposed to find u, right? We were supposed to find e raised to power x. So e raised to power x is equal to 6 or e raised to power x is equal to 2. Now, how can we find x from here, we can take log on both sides. Natural log of e raised to power x equals. Why natural log? Because the base is e. Take natural log on both sides. Natural log of e raised to power x is equal to natural log of 2. So natural log and e cancel each other. So we have x is equal to natural log of 6 and x is equal to natural log of 2. Either we can write answer like this, or we can use calculator to find natural log of 6, which is 1.79, and we can find natural log of 2, which is 0.69. Those are your answers. Next we have how to solve logarithmic equations. Now let's consider these two log equations. The first one has all the terms are in log. This term is in log, this term is log, and this term is log. And this equation, these two terms are in log with the base 3, but the right hand side is only 2. In first equation, all terms have logarithmics. In the second equation is mix of logarithmic and constant terms. So these two equations require different style of solving. The first one can be solved using equivalence property of logarithmics, which states if we have log of x with the base b equal to log of y with the base b, if the base is same on both sides and both sides of the equation is log, then the argument should be equal to each other. X should be equal to y. Let's use this property here in example number 6. Solve logarithmic equation using equivalence property. Now if you notice, both sides we have log terms, base is same. Equivalence property applies only if the base is same. That means the argument using equivalence property, we have 3x minus 4 is equal to x plus 2. Now we gotten rid of log. We can solve this by isolating x. We can subtract x on both sides. We will have 3x minus x, and we can add 4 on both sides, would be equal to 6. So 2x is equal to 6. Dividing by 2 on both sides, we have 3. So x is equal to 3 is the answer to the problem, solution to the equation. Example number 7 is also the same kind of log equation. Both sides, all the terms are in the log expression, and they're all natural log in this A part. So let's make using quotient property first. Natural log of x minus 4 can be written as natural log of x plus 6 divided by x. So what did I use here? I used quotient property. Now both sides of the equation is one log term, and they both are natural log. That means their argument should be same. So using equivalence, x minus 4 should be equal to x plus 6 divided by x. We can use the cross multiplication. We would have x times x minus 4 is equal to x plus 6. X squared minus 4x is equal to x plus 6. That would look like a quadratic equation. X squared minus 5x minus 6 is equal to 0. X minus 6 times x plus 1 equal to 0. I factored the quadratic equation. So x is either 6 or negative 1. So we have our two solutions. But in log equations, always check your answer, meaning try x is equal to 6 in the given equation. So log of, natural log of 6 minus 4. The question is, it should be equal to, is it equal to natural log of 6 plus 6 minus natural log of 6. This is natural log of 2. This is natural log of 12 minus natural log of 6, which would be natural log of 12 by 6, and which would be same as natural log of 2. So we have, they are equal to each other. So we are good, right? So this is a solution. We also need to check x is equal to negative 1. Let's see. The equation was natural log of x minus 4, negative 1 minus 4. Is this equal to natural log of negative 1 plus 6 minus natural log of negative 1? Now, log is not defined for negative numbers. So, this is not defined. So, this is not solution. So, only solution you can take is x is equal to 6. We have to cross this one. Why? Because log cannot have a negative value. Let's work off part B on question number 7. We have log of 3x minus 4 minus log of x plus 1 is equal to log of 2. All the terms are log terms. They are common log. But the left hand side is 2 log terms. So I'm going to use using quotient property first to make them 1 log. See how those properties which we did in last section help us here. This can be written as 3x minus 4 divided by x plus 1 using log property. Now, both side is 1 log and they are common logs. So using equivalence, we have 3x minus 4 divided by x plus 1 is equal to 2. We can use the cross multiplication. So we have 3x minus 4 is equal to 2 times x plus 1. 3x minus 4 is equal to 2x plus 2. Isolate x is equal to 6. So we have our solution. But remember, in log, we always need to check. Meaning, in the given equation, we need to check if 6 is the solution. So log of 3 times 6 minus 4 minus log of 6 plus 1. The question is to check, question mark, is this equal to log of 2? Let's try. Log of 3 times 6 minus 4 is log of 18 minus 4 is 14 minus log of 7. Using quotient rule, that can be written as this, and which is same as log of 2. So which is equal to log of 2. So the solution is a solution to the problem. X is equal to